Cool.
Hey.
Awesome.
Right, we're good.
Hello, everyone. Can you hear me fine? Awesome. Internet problems. So, welcome to our talk on animating joy with Rive. Before we begin, just to let you know, we have a lot of animations which include some flashing imagery. So if you have a problem with that, please just let us know. Who are we? So I'm Vish, and this is Chris.
Hello.
And we're lead engineers at Zoe. And this is our friend Ziggy. He's a gut bug, and he's our mascot. And you'll be learning a lot more about Ziggy and how he fits into our journey later today. But what is Zoe? Zoe is the science and nutrition company on a mission to improve the health of millions. You might know us from our early days where we created the COVID symptom tracking app, or more recently where we ran the world's largest gut microbiome study and used that data to create products like our Daily 30 Gut Booster, our Science and Nutrition podcast, which is the largest in the world, and most importantly, our mobile app. Speaking of our mobile app, this is Zoe 1.0. It's an app we had about 2 years ago. And the idea is simple. You take a photo of a meal, it identifies what ingredients are in the meal, and it identifies a personalized score for you. So the daily loop was you take a photo for every meal you eat and you log it. With Zoe 1.0, we had a fully functional product that worked. However, users didn't really enjoy doing the action every day. I'm sure you're well aware when you do something every single day, it becomes a little tedious. And at Zoe, we felt that eating should feel joyful, and the app should feel alive, and that you do want to come back and do this every single day. And that led us to that question of, what is joy?
Thank you. So, what is joy? Joy is actually incredibly personal. It's an emotion, and it means different things to different people. For me, I get a lot of joy out making coffee in the morning. I am a cliche software engineer. I enjoy making the espresso, grinding the beans, dialing it in. My wife probably would get more joy out of smashing the coffee machine, frankly. As to say, it means different things to different people. So if joy means something else, how are we supposed to translate that into code? Now, at Zoe, we saw animations as an opportunity to create joy. Animations in particular have well-studied and universally recognized patterns for joy. And Disney have been doing this since the 1930s. They started out with all their cartoon animations and things, and they brought about something called the 12 Principles of Animation, which was later studied better in the 80s. And these animations can be used to create something that feels organic, fluid, and alive. And through this, we can create moments of joy. Now, I'll talk through 4 of these. They're 12 principles that they have. But let's start on the left here. So we have this cube that's got some weight behind it. It's going to flip over, but just before it pauses and then it falls. And it creates this moment of anticipation, and it feels alive. It's just a cube. It's not alive, but it makes it feel alive. Arcs is to do with the way that our world has physics, which is predictable. So objects can go in a straight line, or they can go in an arc. Think about throwing a ball and how it returns. If you create animations which follow the laws of physics, just about, it feels organic, fluid, alive. Secondary actions can be used to enhance primary actions. So in this case, we have a cube which is rotating and flying over, but because it's so powerful, it throws this secondary cube high into the air, and then it lands, emphasizing the power behind it. And then finally, on this side here, exaggeration. This little cube wants to go up and eat this other cube, but it doesn't just do that. It launches itself into the air, expands, opens a big jaw, and dramatically closes. So it's something we expect, but it's an exaggerated form. And we can use these to create something that feels organic and alive and create moments of joy. And once you recognize these patterns, you'll start to see them everywhere. It's used in TV, cartoons, and UI. So taking these design principles, our motion designer at Zoe, Josh Noon, give him a shout out there, He used Adobe After Effects, which is a suite used to create motion design widely in the industry, to create this, which is a video. Okay, this is what ended up being a motion specification for our piece of work, but it is a video. It's abstracted away from the application code. And I don't know about you, if you were given this as a design brief in your app, you should have a sense of fear in you. If you do not have a sense of fear, you should be. So we were given this alongside something called a motion spec, which is the data of the design. Think about how long an animation may take, the timings of transition between those animations. And that was our task to work on. And it leaves the question, can this be done in React Native? And you may hear the voice of the Lord of React Native skier, William Candion. So can it be done in React Native?
So when they ask this question, my honest answer is maybe. Anytime you come to do anything in React Native that involves motion or animations or requires a lot of performance, this should be a real answer. And this is actually what we built. This is live in production today. As you can see, not only were we able to deliver everything in the motion spec, we were able to go above and beyond. We were able to add vector animations, particle effects, all running at a smooth 60 frames per second on our React Native app without any stutter. So how do we go about achieving this? If we break it down and look at that very first frame, what we have is Ziggy. And Ziggy starts animating, right? And then the card slides and fades in. Ziggy reaches the peak, pauses. At this point, the card has finished animating. And then after a delay, Ziggy slides out. So you've got those motion principles we talked about earlier, that sense of exaggeration and then the anticipation event while he pauses and then he leaves. Now, when we were building this out and we break it down, we realized that there was a lot we could already do with our current animation stack, which involves reanimated. The fades, the slides, the changing of sizes, all of that was possible with reanimated. But what we couldn't achieve is Ziggy, the particle effects, and all the vector graphics that we wanted to do to make this truly come to life. And to achieve that, we went on a journey to consider multiple different options. The first one we considered were GIFs. Now, anyone that's worked with GIFs knows that they're large, they don't offer any interactivity, they have a fixed resolution, and ultimately, to have all the different poses of Ziggy that we needed, it would almost triple our app bundle size. This was a no-go from the start. We considered Lottie, which had limited runtime logic and no true state-driven animations, which also meant that to achieve all the poses of Ziggy we wanted, we'd have to have multiple large Lottie files. Also a no-go. We considered Skier a fan favorite amongst developers. However, Skier is time-consuming. It's hard to design visually, and it shifts the burden of design onto developers rather than designers. And that's something we didn't want. We wanted our designers to be able to create Ziggy, create the particle effects, and us as developers to be able to consume it. And this led us to a journey to discover a tool called Rive. So, what is Rive?
Well, that's what we're here for. Rive can be described as Figma meets motion design, remembering those motion design principles that we talked about earlier. Rive is an editor, a runtime, and a canvas-based renderer that allows designers and engineers alike to bring motion design to life. That's kind of what it is. It powers websites, mobile apps, car UI, hardware UI, and even products you're probably using already. It powers a lot of UI in video games. Notion AI notably uses it. You may have recognized some of that animation recently. And most notably, Duolingo uses it extensively throughout their app. Now, what does it enable us to do? Because we are able to do animations through other things, but Rive offers something unique. Now, first of all, it's real animations. There's no pre-rendering. It's not going and rendering and saving videos and serving them. Everything is being updated and served to you live. And this is a real frame rate on the screen that was coming out. 6060, there enough. It performs really well. It has an interactive state. You can invoke inputs which trigger animations and they render and animate live. But more than that, you can get live updates back from Rive as animations progress. We'll look a bit more about that in a moment. It's built for designers and developers. So it provides familiar tooling like Figma to be able to create the designs, but also motion design. It creates something that looks like a timeline, which is very similar to Adobe After Effects. So those designers that are coming from those tools find something familiar to them, but it also provides a good API to interact with and patterns which are common to engineers, so we can build with it too. And it's really lightweight, like surprisingly so. I looked at our Ziggy animation here, and we'll have a look at a bit more of what is going on in this spider web in a moment. But we're using over 50 animation routes. We're stacking multiple of those together as well, so it's quite a lot. And we're getting less than 1.5 megabyte asset size for all of that. It's more performant than Lottie and GIFs, it's more configurable, and it has less memory usage. So I'm going to point to you a little bit about what this is, because this is a Rive editor. We're not going to go deep into this, but I want you to feel a little bit familiar. Maybe you could dive deep on your own if you feel so inclined. So this is Rive editor. In the middle, we have a canvas. It feels very similar to what you might see in something like Figma. On the left-hand side, we have this big hierarchy tree, which is kind of like the layers in Figma as well. We have inputs at the bottom down here. These are actually the API interfaces that engineers will use to trigger an animation. And we'll see a little bit more how that interacts with this big spider web here, which is the state machine. It is a bit magical, so I'm hinting here, but not going too deep. There are things like data binding as well, which we will touch on. Now, this is a timeline. This is where Adobe After Effects kind of finds its parallel in Rive. And you can create all the different points of our Ziggy character. And as you can see, as I scrub across the timeline, you can see how all these different indices here are all animating and moving around. So it's quite powerful like that.
Just before anything, I'm very curious. Is it using anything related to SVGs?
I don't think so.
They're vector graphics, so they're not quite SVGs, but they are vectors.
Okay.
So Chris mentioned earlier state machines, and you might be wondering what are those? State machines are the heart of Rive. They truly bridge design and code. They control how animations respond to inputs and events, enabling context-aware motion. So what this truly means is, with a set of inputs like booleans, numbers, or triggers, you can drive animation changes. Each animation configuration depends on a particular state, and you can transition between each of these states based on Boolean logic. So in a particular case, such as a button, states might be idle, pressed, or loading. In this case, we have a state for every star press, and then we have nodes that determine how you get from one star press to the other, which would rely on the number of stars pressed. The truly magical thing about these state machines is they offer interactive control. Developers can trigger these inputs from code, but they can also interrupt the animations at any point during runtime and transition from one state to the other, which truly enables some really game-changing flows. Now, how this all works is the API contract. And at the heart of this is two things: triggers and events. If we go back to our Ziggy example, we want to make Ziggy jump. Ziggy is a Rive asset, and in code, we take the Rive asset, we apply a ref to it, and then we fire an event trigger. And our trigger is Ziggy jump, so he jumps. And then when Ziggy reaches the very top, he fires an event back into our code that we listen on with a listener that we attach to the ref. This allows that two-way stream of information, one to the Rive asset, and then information back from the Rive asset that we can use to either transition or pause or do other things. Now, I know what you're all thinking right now. Wouldn't this be simpler with Lottie or a GIF?
Well, the answer to that is yes and no, as is often with these things. Let's have a look a little bit deeper than that. Now, I'm going to present you a problem that we have. We're going through a logging flow, we're logging food, okay? You take a picture and Ziggy jumps up and he celebrates to you. If you see that same animation every time, it's a little bit repetitive. So what we wanted to do is create a variety of animations, just to spice it up a bit. Now consider how we might build something like this if you use GIFs or Lottie. Let's set out some of the parameters. All of these are different animations. They have different durations attached to them. Some of these animations are being used elsewhere in our application already, and they have a different length attached to them as well. We want to transition to the next screen at a specific point in that animation. We're going to pause it, and we're going to transition to next screen. If we used a GIF or a Lottie file for this, on a Lottie file we could listen to the animation end event, but we'd have to have different Lottie files for animations that we're reusing in our application. With GIFs, we would probably have the hard code as timeout value, and that presents a bunch of problems. If a designer were to change that animation and we're using as hard code as set timeout, we need to now go back in our code and change that. So we're creating a tie between the design and code, which is implicit. So instead, what we can do with Rive is we can have one animation, 4 triggers, and one common event to listen to. And that's what we've done here. We trigger the animation, we listen for the event, which is being fired from Rive, and then that's returned to us and we transition to the next screen. All of the timings for this live in Rive. They're controlled by the designer, not by the engineer. If things change in the future in the design, it will update in the app. We don't have to change anything. And engineers are not burdened with any of the maintenance. And this is another simple example of how we're using it. You go through the login flow, you get rewarded with beans, which is a currency we have in the app. Depending on how well you've done, you get rewarded a different volume of beans. Now we can just trigger one of 4 inputs inside our asset. We don't have to have 4 different assets. And we can extend this in the future, and the interface that an engineer has, it's actually really simple. Now, I actually really love this. One problem we found, or one thing we noticed, I should say, is we have Ziggy on our home screen. Members kept tapping him. We're looking at analytics and members keep tapping. And we thought, you know, this is a really fun opportunity to create a moment of joy. So what we wanted to do is allow our members to tickle him. So you'd start tapping Ziggy and he giggles, you keep tapping him and he'll burst out laughing. And we can achieve this with Rive. And this is how we do it. We have a state machine on the bottom, which goes from right to left. Over here, we have inputs. Remember, these are the things that you're triggering as an engineering code. So we can start a tickle, we can escalate a tickle, and we can end a tickle. And the way it works is as we execute those actions, it will progress along this path here. That's the simplified version here. But we can also do more than this. We could create multiple branches at different points. So different inputs will trigger a transition along the different branches. And hopefully you can see from this, you can create something that's quite complicated quite easily as an engineer.
So one thing we wanted to talk about when we talk about Rive that we can't not mention is data binding. This is a piece of technology that Rive released about 3 months ago, and it truly changes the game. What it does is it allows you to bind values between your React Native layer and your Rive layer, meaning that the Rive animations respond automatically in real time to your data and logic. We're using this quite extensively. On the right hand side, you can see our new home screen. And we have Rive assets, which is the map background. And we bind the colors between our React Native layer and our Rive layer. And what this means is when we switch from light mode to dark mode, the animation changes color in real time without having to restart, without having to refresh in progress. We also bind strings and numbers. In this example, you can see that we have 230 beans. Now this value is stored within our Redux store. And so that means that whenever this value is updating, it's not only just updating in our state, it's updating in the animation in real time. You can also bind Boolean values such as isPlaying, so that both React Native and Rive work off that same value to determine if the animation is playing, as opposed to two values that you have to keep synchronized across a bridge using triggers and events. There can be only one value. We actually use this in more advanced methods as well. This is the new home screen that we're building today. And as you can see, it's more lush with a lot more map design, a lot more fluidity. You've got this particle effect of beams dropping. And we achieve this using advanced data binding features. For the maps, we use enums to determine what parts of the maps we turn on and off. And for when the beams drop, we actually bind this directly to our triggers for haptics, so that the Rive animation itself directly controls what's happening on your phone, as opposed to any piece of React Native code. We're also synchronizing an internal isPlaying, so instead of React Native holding the state value that it's using to drive the animation, it's the Rive asset that's holding this value and using it to drive React Native code. And we use this quite extensively. So in this case, you can see that isPlaying value is not only used to hide that cursor that shows you the number of beans, but also these React Native elements that are tethered to that value. And that brings us to the end of our talk, but not any talk wouldn't be complete without talking about some drawbacks. So Rive, amazing technology. It's still in its infancy, and there are some drawbacks that you should all be aware of. Firstly, there's no support for new architecture on React Native yet. We're talking with the Rive team every single day. We're telling them this is what we want, but it would be amazing if you guys could also flood the GitHub issues thread and tell them exactly what you want as well. Now, Rive has multiple SDKs, and the React Native SDK doesn't get a lot of love compared to all of its other SDKs, which means that doesn't support certain features like data binding lists or data binding artboards quite yet, while other SDKs do. I've talked to them about this, and they tell me they're working on the Flutter SDK at the moment. So once again, exactly, please hound them, please DM them. I'll send you their numbers. But yeah, they are a small team. I do understand, but just be aware of that. And then the final thing is the discrepancies between Android and iOS runtimes. So Rive itself is a C++ runtime that's wrapped for Android and iOS separately. And then those two wrappers are wrapped again with a React Native wrapper around it. Now, what this means is there can be certain discrepancies between the Android version and the iOS version. The iOS version is always much better than the Android version. I think that goes without saying. But Rive do try and keep them quite synchronized, and if there are issues, they do try and fix them quite rapidly. So, just a couple of notes. Thank you all. We are hiring at Zoe, so if you are interested in anything to do with Rive or anything to do with React Native, please do reach out. Let us know, and we'll bump you up the track as well. And then there are certain articles we referenced, so please do give a read, please do give a watch. And thank you all. Do you have any questions?
Quick one.
Yep.
I was very fascinated by the first part with the investigation, and I was wondering how you went about it. So, okay, Skia, did you try to build something like that? Did you were looking for trade-off? Asking ChatGPT, will do that? What factors do you consider?
Yeah, so internally, we had a lot of experience with Reanimated already, so we knew we could do a lot with Reanimated. And we had used Skia previously for other things. We knew the amount of time it took to invest, and it basically led to a lot of duplication, once on the design side and once on the engineering side. With Lottie, we've previously used it for things such as, favoriting bars, etc. So lots of experience there as well. And it just wasn't fit for purpose for what we were trying to achieve. That screen you saw earlier where everything is dropping down, that actually has 120 unique animation frames playing. And with Lottie, it would crash. It just wouldn't be possible. To obtain the frame rates we needed, we did need something new. Unfortunately, we were aware of Rive. None of us had used it, but we knew that Duolingo had lots of good experience with it, and that's how we started researching it. We did a POC, and then we proved it could work, and then we decided that it would be what we go with.
To repeat the question for the sake of the microphone, you're asking how did we go about doing the research phase of this to see if we could use existing tooling?
Rive, you said it doesn't get much love on React Native, but are they supporting something much more than, or it was initially conceived for some other platform? How does it work? React Native is pretty big, so it was wondering.
Yeah, so Rive itself, is a tool that powers many different platforms or works on many different platforms. Some of the platforms that they do support quite extensively include Unity. They support React Web or web in general quite well. They support native iOS quite well, and Android's a bit of a mixed bag. But it's essentially someone writes a C++ runtime, then someone writes the iOS runtime, and then the Android runtime, and then once those are complete, then they do the React Native runtime. So the React Native runtime is always behind where Rive itself is.
Yes, I have a two-part question.
Mm-hmm.
The first one is, well, this looks quite complex in terms of implementation-wise. So I try to understand how much percentage was on the work of the designers to prepare the animations versus the work and effort of the developers in terms of time. Secondly, how much it took you to accomplish this level of quality and why.
So to repeat the question is about how much time did we invest to get the quality of the application, and looking at the design in particular, how much time did we have to invest in the quality of design compared to the application side? Is that
so to compare how much design time took to accomplish this versus engineering time?
Yeah, so the trade-off of design and engineering time and how much you have to invest. So you might want to add to a bit of this. I would say when things are contained within the Rive layer as a standalone animation, the effort feels a lot less. But engineers are going to say that because the work is being offset, right? It's someone else's problem. But at the same time, I think it's probably fair in saying that when there is an interaction that's going on between Rive and React Native, and you're having to do multiple of those points, that's when it starts to get kind of difficult. When we looked at, there was a line with items appearing one after another. If you saw that kind of flow, that was quite challenging, wasn't it? Because we had to have events fire, trigger next things on animations, and there's quite a lot of work involved in that. Anything you want to add?
Yeah, just to add a bit to that, I think one thing to understand is there necessarily isn't just a design handover. With Rive, you're working quite closely with the designer on the Rive asset in the Rive editor, helping them create the state machines. There's a lot more back and forward as opposed to GIFs or PNGs where a designer might give it to you and then you consume it. You will have to go back and ask for triggers and maybe change up the state machine a little bit to get the exact functionality you want. So it's not a linear process. There is a lot more going back and forward. Yeah.
Something that I find useful to think about this is the Rive is building an API layer which you're interacting with. So those inputs are your API integration and the events are the outputs. If you think of it as like a REST API, that's how I envision it. And it is, like you say, it's an interactive process with design. It does change the concept to design quite a bit.
The last part of the question is, if you have to do a percentage-wise, how much time was invested from the design versus engineering? Like 70-30, 50-50, 40?
I'd say 40 design, 60 engineering. Yeah.
On the whole.
On the whole,
yeah. Like maybe it's become easier as we've got used to the process, I would say.
Yeah.
So yeah, that's probably accurate.
It really depends on your use case. When we go to use Ziggy, for example, that's quite an easy flow for us because we know how to use him quite well now, and so does our designer, so we're quite good with that. But when you saw that flow where there are lots of items on the screen and things are coming into frame and out of frame, that one is far more unique and requires a lot more time investment upfront from both design and engineering.
I'm a React JS developer, so on the JS DOM. So my first question is, when did you find Rive? Did you check out those things like, obviously you have seen JAF, Lottie, and what about APNG and MP4s, something like that? I think MP4 will be, video files will be much higher in size. So that's my first question.
Yes.
To repeat it, just so we got people can hear this. So the question is like, how did we how did we arrive at Rive? How did we find it?
Yeah, so that's a really good question, and we did consider all of these options. Even when we were building it, a lot of people asked internally, who are here today, wouldn't it be easier with a GIF? So it's every time we went to use a GIF, we compromised, and we got tired of compromising, and we wanted a tool that allowed us not to compromise and truly exceeded what we wanted to build in the first place. So that's probably the reason we arrived at Rive. It was the only tool in the set of tools we explored that allowed for a zero compromise solution of the vision. That original piece that Josh created in After Effects, running at 60 frames per second, we just couldn't do with all the other tools.
Yeah. How about the performance? And what is the
I'm really sorry to interrupt. Let's just try and do one question per person, just because of the time.
Okay.
We've got time for 2 or 3 more questions. You can always chat with them afterwards. But let's just
awesome.
Try to get everyone a chance to ask questions.
Have like UI UX team that will complain when you said that you Rive. So how did you manage that when you decided to go to Rive to discuss it with the UI UX?
Yeah, so the question is, do we have a UI UX team when we started using Rive? How did that play out in the field? So we have a dedicated motion designer, Josh, who is amazing at what he does. A lot of this work was kind of done in isolation to begin with. Where it's become interesting is we have a design system that lives in our app, which has helped unify a lot of our UI framework. Together, it's really like pushed our quality bar. What we're finding now is we're trying to add in new types of animations, and there's a crossover happening. And this problem you're presenting of like, how do we make these things live? We're still wrestling with that, and we haven't got a good answer, I'm afraid. I feel like we're on the top of what's possible sometimes. So there is a tension. Communication helps a lot, frankly. I think it's underrated as a soft skill in this sort of endeavor. But I think keeping things isolated and separated as a separate component is useful. But there are things like we have a day streak component. I'm not sure if it was in animation, which is a little tick. And that's the first point of crossover we found. And it's been quite difficult to resolve that because we do have a duplication at the moment between what we see in our library and what we see within Rive. I'm not sure. Anything to add?
Yeah, I think it's an ongoing process. We've done a lot of work to make sure that our design system works between Rive, Figma, and React Native. Things such as data binding help a lot to keep all those values in check. So it's an ongoing conversation, definitely within the design team as well. Yeah. Whose hand is up first? Sorry. Yeah.
So I would be interested about like best practices that you have found in the process in general, no? So for example, in terms of splitting I imagine in the end is what Chris was saying as well, no? You are creating an API. So I can guess this will grow in complexity. Have you found that you have had to split the different assets, for example, for theory, and like are there concerns about, for example, bundle size? Assets? What would you say to that?
So to repeat again, the question is, how do we deal with this as complexity grows and having a single asset feels like it's complicated? We're building an API and it's all living in Rive, and that creates complication as well. So that's absolutely true. We have definitely seen that. I would say the biggest challenge for us as engineers is that the API schema lives within Rive and there's no way to expose the metadata. That to me scares me because I can't know when the Rive asset change, which is a binary file, if it breaks an API integration. We have no automated way. The way we solve that is through end-to-end tests, which you have to do, I feel, is kind of a requirement of that. As for it growing in complexity over time, that is a challenge. Rive have introduced something called libraries, which I think solve some of that problem. Again, this is very new, so we've built some of this before it really came about. But I feel like that's part of the answer to the problem there. Another solution is organization. Something we've been exploring only today was the use of enums, so you can split out inputs into enums and data bind them. This is a bit advanced, but there's a way of organizing your inputs in a way that at least feel organized and tangible. But there is definitely a challenge between integrating the native asset back down to React Native, which I feel a little uncomfortable, but end-to-end tests so far saved us.
All right, sorry, there's no more time for questions. I've got a bunch as well, but yeah, let's give a hand.
Okay.
We're gonna go straight into a 5-minute break. We're gonna have to be a little strict with the break times because we want to squeeze in Nick's